Okay, so in today's session, I want to help you understand two things. One is what is Medallion architecture, Lakehouse Medallion architecture. That's general question that you should understand. Second thing is if you are asked for an architecture question, maybe in the interview or when you are working in project and you are supposed to build a solution architecture, at least high level solution architecture, how you should think and how you should frame your solution. So those two things I wanted to talk today. So let me share my screen and start the discussion. So you take up any data engineering system, right? Any data engineering platform for batch processing or for near real-time stream processing. Real-time stream processing, when you have a requirement to take action on the data within milliseconds, goes in completely different architecture. That's something we have to follow Kappa architecture that I talked earlier. This architecture is excellent if you have a data which is generated at some source or some point, and within milliseconds you want to take some action on that data. For those kind of requirements, Spark or Spark streaming are not suitable. But if you have a requirement where you need to take action on the data on maybe every minute, or maybe in 5 minutes, 10 minutes, or on daily basis or weekly or monthly basis, Spark is excellent. Uh, it's top notch, the best system for building those kind of data engineering solutions. So keep that in mind, that Spark is your or Databricks is a platform which allows you to build batch processing systems and near real time stream processing systems. But how do you architect a solution, or how do you design an end-to-end solution architecture? You take up any system. It's all of those systems fall into a common architecture framework or architecture pattern, right? So every system, end of the day, it is we are we will be fitting into a common framework, common architecture, and that's what we are going to learn in this session. I'm going to explain that today, and that modern architecture pattern that is recommended and being followed nowadays is known as Lakehouse Medallion architecture. Everyone is talking about it. So what is Lakehouse Medallion architecture? Uh, Terminology wise, there are two terms, Lakehouse and Medallion, right? Architecture is just an architecture, right? So Lakehouse and Medallion. So what does Lakehouse means and what does Medallion means? Try to understand these two terms. It's just terminology. So Lakehouse is a combination of two half words taken from two full words. Lake, house, there are two half words, lake and house. So lake is taken from data lake and house is taken from data warehouse. So from warehouse. And they combine these two terms to make a new term called Lakehouse. It's a made up word, right? So, and what they mean by Lakehouse is a solution or a architecture pattern which comes with all the benefits of data lake and also all the benefits of data warehouse. And that's what they call Lakehouse. When they say all the benefits of data lake, they basically mean we can handle volume, velocity, and variety of data. And when they say all the benefits of data warehouse, then what they mean is we can build reports at high speed. The system performs to the expectation or to the speed of data warehouses or databases, and we can build data models. We and we can have standard connectivity with the system. like data warehouse, will have a standard connectivity from various systems. And yeah, so that's what they mean by data warehouse benefits. And along with that, there are a few other capabilities that data lake was missing, like you can have transactional systems, you can have data integrity, and to some extent you can also have constraints and those features which might be helpful building your data models or managing your data integrity. So all those benefits combined together into a single architecture is what they mean by Lakehouse architecture. That's the first term, right? So hope that makes sense. So Lakehouse means all the benefits of data lake: volume, velocity, and variety. House means all the benefits of warehouse, like transactional systems, data modeling capabilities, standard connectivity, and performance. So you combine it and call it Lakehouse. What is Medallion in the architecture? What is Medallion? So what they say is Medallion means you design your solution in multiple layers, right? And that's what they mention here: bronze layer, silver layer, and gold layer. So what does this layer means? That means you segregate or create clear compartments or boundaries of data zones. And you can have a clear cut objective performance criteria, um, and you can define different features uh, at a data zone level, and break your entire data journey into different zones. So what they say is minimum you should consider creating 3 data zones. The first one they call it bronze layer zone, or bronze data zone, or bronze layer simply. The second one they call silver layer, and the last one they call gold. And these naming are given based on the level of data quality that you have, right? So what they say is bronze layer you is a separation of your data zone which contains all your raw data without any modification, the single source of truth. Whatever is captured by the data producers or your operational systems, keep it as it is, whatever you received, without any modification, without any change. And that's what we call raw data, and we call it bronze layer. It's just a name they gave it, bronze layer zone, or we can call it raw data zone. So data quality at the bronze layer is lowest because you have raw data. You may have duplicates, you may have some columns which are missing, you may have incorrect data, you may have different kind of problems. You may have data formats mismatching, everything is not following a standard format, dates are coming as strings, some records dates are coming as numeric value, dates are coming in UTC format, dates are coming in timestamps are coming in EST or PDT time zone. All those kind of problems are there. It's not standardized because what you did, you collected data from source as it is and preserved the original copy of the data in the bronze layer or your raw layer, and keep it separate. That's the idea. Maybe create a boundary around it. How do you create a boundary? Maybe you create a database, a separate database, called it bronze DB, and all the tables in the bronze layer are part of that separate database. And then you can also define storage characteristics for your bronze DB. Maybe you can use a cheap storage there, built on hard disks, because or maybe you buy a different plan from your cloud storage provider, which is less expensive for the bronze layer zone, or whatever. How critical and how important is this? You decide it on that basis, right? So create it separate and define all the features, all the quality, infrastructure, everything. You can keep it separate, and that's why they say create one layer of the bronze, separate layer. And then next layer is silver layer. Why they call it silver? From bronze to silver, your data quality is improved, right? So what the architecture pattern says, that you take data from bronze layer and recreate tables or fill data into a separate layer which is called silver layer. And in the silver layer, you improve the data quality. So what does it mean? If you have duplicates here, maybe remove the duplicates and keep only valid unique records in the silver layer. Maybe if you are building some data model like a star schema or a snowflake, you create your dimension tables in the silver layer. Even you can create your fact tables in the silver layer. Make sure your data quality is improved. You are fixing all the data quality issues moving data from bronze to silver layer. So one single agenda here from moving data from bronze layer to silver layer is to fix the data quality issues and prepare standardized data structures or data tables in the silver layer. Those tables may be your data model tables like dimensions or facts, or it could be a simple entity tables. For each entity, you create one table and fill it here. But idea is to improve the quality as you move data from one layer to another layer. So remove all duplicates, fix all the formats, like some simple things like or things that are part of almost every project, right? So like if you are collecting data dates, make sure all the date formats are standardized. You are following either YYYYMMDD or DDMM or whatever. Everything is standardized here. If you are handling time zone information, make sure every entire silver layer is in the single time zone, maybe UTC or GMT or whatever you decide, right? So all the duplicates are filtered out. All the null values are taken care of. If it is okay to have null, you bring it there. But if null values are not okay, you fill it with some default values or some computed values or derived values. Do whatever you have to do to improve the data quality and bring your clean high quality data. Along the way, you can also do an augmentation, like you add some additional fields to your silver layer tables, or you maybe join and create a pre-joined bucketed tables in the silver layer. So all those kind of things you can do. But in summary, we call it filtered data, means we filter out the bad quality data and keep only good quality data. We clean data means we fix the data issues, make it clean and keep it here. And augmented, we augment data with additional information if that is required for my use case. So that's what we do in the filter silver layer. And the final is the gold layer. Why we call it gold? Because the data quality improves further from the silver to gold. And uh, how data quality improves? Because all the data quality issues you already fixed here itself, right? So maybe data quality is not going to increase further into gold layer, but still there are some issues which you cannot fix in silver layer. Like if data is coming, if you are computing some aggregates and some data is coming late, so maybe that late data arrival is some late data is missing in the silver layer. But when you can calculate the gold layer, you make sure all the late data is also taken care, and you calculate the correct aggregates here. So few issues which you couldn't solve in silver layer can be solved in the gold layer, just because you needed one more extra hop to solve that problem. So you will encounter those kind of problems. But more than the data quality, we call it gold layer because this is the copy which will be consumed by our end consumers. So for end consumers, this is the gold. This is the gold mine, right? Based on this, they are going to make data-driven decisions. So that's why we call it gold layer. Gold layer doesn't mean that it is always aggregated. It could be any form of data which is ready for consumption by the end users or the consumers or the business processes that want to make data-driven decisions or develop data-driven applications. So an idea is that in large project, you keep it in a separate database. This one you can create silver DB. This one you can create gold DB. You can have different kind of security rules at different layer. You can have different kind of storage design for different layer. For example, for gold layer, the volumes will be less here. Maybe half of the things are aggregated here, summary tables. And so this you can build using a storage layer which is made up of SSDs, which is little expensive, but it will boost the performance for these guys. They can access it quickly. The reason for the Medallion architecture says that take an approach of breaking multiple layers of your system based on the data, right? So you break your system into multiple data zones, and that's what the idea of Medallion architecture is. So you have why you do that? Because you want to have a freedom to design each layer and its properties and its characteristics uh, based on the requirement. You may want to use this layer as the fastest layer, most expensive, what you call most expensive storage, uh, or the fastest storage possible. This is your most critical part. So maybe you want to implement um, a disaster recovery for more strong disaster recovery for this. You copy this to some other zone. So all those the idea is that since these layers are broken into different, your system is broken into different layers, so you have the freedom to design each layer separately. That's the idea of Medallion architecture, and that's what is all. That's what the Lakehouse Medallion architecture is all about. Lakehouse Medallion architecture says, do it this way, right? One more thing is the recommendation for Lakehouse Medallion architecture is that you decouple your data ingestion from the data engineering platform, and that's a very crucial design idea. What we say is this is your data in engineering platform, right? You and your data is sitting at some source system. You are supposed to collect your data from the source system, but idea is that this platform, all you are doing, whatever you are doing here, should be decoupled from the data ingestion. And what do we mean by decoupling? Decoupling means if anything goes wrong with the data ingestion pipeline, your this platform should not be impacted. If you are shutting down your data ingestion pipeline for modification or for redeployment, you don't have to shut down this entire thing. Everything here keeps on as it is, it running, or as it is, or it's not at all impacted with what you are doing with the data ingestion pipeline. And how to achieve that? They came up with a simple idea that create a landing zone. And this is very old idea. I mean, in data warehouses world, if you have worked in the data warehouses, we always used to have a staging area or a landing zone where when we ingest data from sources, we keep it there for temporary duration, for a short duration, for a temporary purpose, maybe 1 week, or uh, for even shorter than that. So the idea of this architecture, since it inherits a lot of qualities and features from the data warehousing, they came up with this idea that you create a landing zone here, which could be the cheapest possible storage, which is like your cloud storage. If you are in Azure, this could be a ADLS directory or set of ADLS directories. And if you are in Amazon cloud, it could be S3. So what they're saying is keep your data ingestion separate. You can ingest data using a batch ingestion tool. You can ingest data using a stream ingestion tool. But whatever your data ingestion pipeline is, it should end with dumping data in your landing zone in form of files or putting it in the directories, right? So and that solves a lot of problem for you. The idea is that if you are collecting batch data, you keep it here, and then from here you start thinking how do you build your bronze layer, which is raw data. This is also raw data. You are collecting and dumping it here in the landing zone. But from here you start thinking how do you build your bronze layer in the best possible way. And basically bronze layer you will be building using delta tables. It won't be files, data files lying in some directory. You will build a database, you will build create delta tables and create your bronze layer with the delta tables. But this could be your files, and this solves a lot of problems. Think of it. You have a pipeline which is reading data from landing zone and inserting into your bronze layer raw table. Since it's a raw data ingestion, this is also part of your data ingestion, right? So this is since this is a raw data ingestion, uh, you are not applying any transformation, any data quality check, nothing. It's simply copying from this landing zone to delta table, right? Suppose your batch ingestion pipeline is broken, or it stopped ingesting data or collecting data or bringing data here, or you are changing your batch ingestion pipeline and you stopped it and you want to redeploy it. So you stopped this part, but this part keeps on running. No new data is coming in the landing zone, so this part will not ingest anything new, but you can keep it running. You don't have to stop this and restart this because your data ingestion is think of it this as a single pipeline, or then stopping data ingestion will stop everything. And then if you are stopping everything, then restarting everything again, you have to take care of how do we restart it. Is there any complication restarting it? How do I manage those complications? So the idea is that use the landing zone as your breaking point, decoupling point, whatever you call, right? And that gives you a lot of flexibility. Think of a small file problem. You are doing a streaming ingestion. Every second, maybe every minute, you are creating files in the landing zone, right? All those small file problems are here. But when you are moving data from here to here, you can take care of the small file problem once for all, right? Ingest data from here to here in these tables and make sure you are not ingesting uh, small files and creating you fix that problem here itself, and then rest of the entire system is free from the small file problem, right? So the point is that this is one of the most crucial idea of a Medallion, Lakehouse Medallion architecture, that use a landing zone to decouple your data ingestion from rest of the data processing pipeline. That's an architectural pattern, right? So that's high level at the Medallion architecture or Lakehouse Medallion architecture. Now think of it that you are given a requirement to design a system, and you are asked to build a end-to-end architecture, maybe high level, not to not up to the details of every job and everything. So how will you approach it? So start thinking from your uh, data sources. What are your data sources? How you will collect data, or from where you are going to collect data. And once you know, okay, these are my data sources, then uh, build a pipeline, data ingestion pipeline from the source, end it at the landing zone. That's all. One data ingestion part is done. You don't have to think rest of it at the same time. You only think about ingesting data into the landing zone. So your thinking also, or your design, you are basically breaking your problem into small pieces and then concentrating on each piece at a time, which simplifies the way you build the solution, right? So now let's take one simple example and try to understand how do I think about it. So here is one example. Architecture diagram or a solution design at high level have built to understand how do we build the solution, or how do you start thinking about the architecture of a data engineering system. So think of it, this is like a Fitbit kind of device. Your company is uh, involved in building or selling wearable device. So you are given a task to build a data engineering system and provide data to your consumers. So you got your requirement from your consumers, and what based on the requirement, and of you start thinking from here, from the rightmost, right? Because your goal of your system is to facilitate data for your end consumers, right? So your end consumers are the ones who will give you requirement. So if they are giving a requirement that I need this kind of data, so they gave us a requirement that I need a workout BPM summary for building the reports that I need to build, and I need gym summary. So I'll start with this. So I'll conceptualize my gold layer first, because that is what they are going to see. They are not concerned with all this headache, how we are achieving this. So I'll start with this. First task for me to design a solution is to model the gold layer for my consumers, that what they want. I'll work out with them with all details. Okay, what do you want in this summary? how you are going to use it, what kind of report you will build, and what data you want, do you need, and then I'll figure out what kind of data model they will be suitable for them. So in this example, I figured out, okay, flat data model is enough for them. So it's basically one single flat table with 20, 30, 50, or 100 columns, some kind of information, some level of aggregation. This is the flat table they want. So I came up with the flat table design for my consumers. Similarly, two flat tables, it's a small requirement. So I came up with this. We are not going into the details of what are these, what are the columns in this. So, but I'm just helping you to understand the thought process. So I came up with this, and then I start working backward to identify what data do I need to prepare these things, because this is my end goal. This is fixed. This is firmed. I've designed it. Maybe I put some sample data here for them and ask them to test it. If they are happy with that, then I'll work out the rest of the system. So once this is done, then I'll start working backward and thinking what data they need, or what data I need to prepare to reach this goal. And then I identified, okay, I need 5 data sets. One is user or device registration data set. I need login, logout events. I need user profile, latest, all the user profile updates. I need all the pulse or the events sent by this device. I call it BPM stream. I need workout sessions, all. So basically, I need 5 data sets. And then I started figuring out that where all those 5 data sets are uh, stored. So then I realized, okay, I worked with the operational systems. I realized, okay, these 2 data sets are available in Azure database in my Azure cloud, or company's Azure cloud. The database is Azure SQL. These database, they are already collecting in Kafka topics in the Kafka cluster, because this is all stream kind of data sets. So we already have a system in place where operational system basically in place where these 2 data sets are available in database, and these 3 data sets are in Kafka topic. Now my work starts. How do I start designing the system? So I know the first step is to create some landing zones for my data input data sets, and build a data ingestion pipeline. Choose best suitable tools for ingesting data from the source and dump it in my landing zone. That's all. If I do that, my data ingestion design is done. So what I did is I figured out, okay, from ingesting Azure SQL data, I can use Azure Data Factory and sync the all the changes. I can implement CDC from Azure SQL database using Azure Data Factory. It's very easy. And I'll dump the CDC data into these 2 landing zones. These are nothing but ADLS directories. I'll preserve it here. And this pipeline will keep on running. It will keep on bringing new data and keep on dumping into the landing zone. That's all. This ingestion is done. I start working on the how do I ingest from the Kafka, and I realize that the most suitable is ingestion mechanism is Kafka Connect. So I'll use Kafka Connect. I'll spin up a Kafka Connect, a small Kafka Connect cluster, which will connect to Kafka topic. Whatever topics are there, will collect data from all the topics. In my case, I have 3 topics, but maybe I have 50 topics. So collect data from all the 50 topics and dump it into one single landing zone, Kafka multiplex directory. Because why I can manage to dump it into a single location, because all the schema for a Kafka dataset is same, right? It's Kafka is always a key value pair. So when I'm ingesting data from Kafka, I'll get key value, maybe topic name, maybe timestamp when this data was created in the Kafka, or maybe a few other information. But all that is standard for all the topics, even if there are 100 topics. So this pipeline is super easy. I dump it into a single directory. Each topic data will be different, but high level structure is same, right? So I simplified all that. And this pipeline becomes super simple. And I don't have to code. I can use Kafka Connect. It will be simple configuration and I can ingest it. So my data ingestion is done. My data ingestion design is done. Now think of it how I start working forward about the design. So I know I'm going to follow Lakehouse Medallion architecture, and at the minimum, I have to design bronze layer, silver layer, and gold layer. I already worked out my gold layer design based on the requirement. All I have to do is to build my silver layer and bronze layer. So, and that is simple. That is simple. As soon as I figured out what are my data sets, I can start creating, without thinking too much, I can start creating delta tables in my bronze layer. So I have, I know this registration data set, I can create one table. For login, logout events and whatever details are there, I can create one more table. And for Kafka, I can create a single table where all Kafka topic can come, because the schema for all the high level, top level schema for all the records, no matter from which topic it is coming, is will be same. So this table is like 5-6 columns: key, value, topic name, timestamp, maybe source system, or maybe few other things, right? So I created one table for this, called Kafka multiplex table or whatever, and done. My bronze layer is done. So there is no big thing in designing this. It becomes very simple. So the idea is we think in compartments, or we narrow down our problems, or break the bigger problem into smaller pieces, and then start thinking about it. So we build this, and after that, now I know that I have to start thinking about silver layer. So first level of silver layer design is super simple. All I have to do is to identify how many entities I have, and for each entity I'll create at least one table, right? So I know I have, this registration is coming, that is user and device registration. So I'll create one entity, which is users entity, then gym logs entity, then user profile entity, heart rate entity, workouts entity. So it's a small example, so I have 5 entities. But if you are doing big project, then maybe you have 100, 200, 150 entities. But designing first level of silver layer is super simple. Identify your entity and just start making tables for each entity, and then we think about how do we fill these entity tables, right? So I've done this, and then once your first level of silver layer is done, then you start thinking, okay, maybe you can create one more layer. You call it your intermediate layer or whatever, but you can keep it in the silver layer also. Then once I have the entities, it means I have all the high quality data that I need to reach here. And that's where all the skills and knowledge and your transformation or your capability as a data engineer starts. Up to here, all looks like mechanical kind of work. There is not much brain you have to apply. All the brain you have to apply from how do you reach from your data, from your entity data to your target, right? How all that transformation will work out. So when I worked out, I realized, okay, I have to create 3 intermediate tables here, maybe user bins, maybe this, and then combining this and this, I can generate this report, and combining this and this, I can generate this report. And that's why I came up with the, so all the brain that you have to apply is here. How do you reach from your entity or your data sets to your final goal or the output that you want to prepare, right? That's how we do a design, high level solution design. And once you have this, then rest all is workflows or your jobs or your code, right? So think of it, each line. I've collected user registration data, I need to fill this bronze layer table. So I'll create a Spark job here, from here to here for this. So this line represents one Spark job that will read data from this and fill into this. This line represents another Spark job, which will read data from this landing zone and fill into this. I don't need to do any transformation here because I'm building raw layer or my bronze layer. No transformation, no data quality check, nothing. All I have to do is to copy here. So this is going to be my one job. Now, how do you implement this job, this one job, right? That is the deep level design or the second level design. High level design is done. I know all these 3 lines represent my jobs for the bronze layer. These gray lines represent my jobs for the silver layer. So this line and this line represents one Spark job. So I know I need to write one Spark job, which will take this as a source, this as a source, combine these things and apply some transformation to build this table. That's a small piece of job, and I can assign this to one team member. So this high level design gives me a clear cut understanding of what kind of jobs I need to write. What are my bronze layer jobs? What are my silver layer jobs? These all yellow are my gold layer jobs, right? And I'm done with the high level design. This explains everything we need to build for our system. Then going down one level below, it starts picking up all these jobs, that how do you build this job, or how do you build this job, so how do you create this job. Maybe that's something tech leads or maybe a architect's role to understand how what is the most efficient or the best way to build this job. If I have to do, maybe I will write a Spark streaming code using autoloader, right? So and that's all, one maybe 5, 10, 20 lines of code using a Spark streaming code using autoloader, and this job is done. So and this design also gives me to make modules in my source in my application code, right? So one module is like your bronze layer module. These three jobs, one module, you can build a modular architecture or modular source structure, right? Different uh, packages or different libraries, you can build that, right? You can also take a decision for each line here, that do you want to do this job as a batch, or you want to do this job as a streaming. And that's the biggest advantage of using a Spark and Lakehouse Medallion architecture. So I can write this using a Spark streaming autoloader, because that's the simplest way of doing this kind of ingestion, right? And this becomes a streaming job. And maybe I want to do this as a batch. So maybe on user every day, end of the day, I want to. So what I need to do, write a Spark job or a Spark code, which will read data from this table, bronze layer, apply all the data quality checks that we want to implement, fix all the data quality. Maybe in this diagram, there is nothing like enrichment, but maybe if you have some other lookup tables, you want to join them with this and enrich and then fill into users table, this job will take care of all that enrichment. And end of the end goal is to fill this table. I can write it using batch processing code. So this part is your stream processing, this part is your batch processing. How do you orchestrate this entire thing as a in the system? What scheduling will be required? How do you schedule which one will run when? That is the last problem, right? So the idea is, as an architect, what we do, we pick up a design pattern, the architecture pattern. And for data engineering, recommendation is you pick up a Medallion architecture, Lakehouse Medallion architecture pattern, as long as you have batch or near real-time stream processing requirement. And then start breaking it into smaller areas and start working on the each area. Start working on the ingestion, which tool, how you will ingest in real time or you will ingest in batch, what should be the frequency. And you don't have to apply a lot of brain, because end goal is to dump it into some landing zone, which is a temporary storage area, right? Once this is done, then you start thinking about bronze layer. Once that is done, you start thinking about silver layer. Once that is done, compare it whether you meet your gold layer or not. You started actually from gold layer. And once all that is done, then you start thinking about orchestration and scheduling. And then once that is also done, then you start thinking about how do you create these assets, right? All these tables. So what will be your setup script? How will you deploy it in different environments? So how your deployment strategy will be, and then how will you test it, right? So how your testing strategy would be. How do you secure this? Which platform you are going to use this? Maybe in Databricks. So how do you want to separate these layers? Do you want to create separate databases for each layer, or do you want to keep one database and keep everything here? What naming convention you are going to use to identify what is the bronze layer table, if you are keeping all of this into single database. So once your high level design is there, then you can start detailing it out. And your team or the technical experts are instrumental in helping you to formulate this. So that's what I wanted to cover as to help you understand what is Lakehouse Medallion architecture and how do we approach for a system design or for a data engineering solution design when we are given a problem, right? And hope it made sense.